Hello everyone. Is my voice is audible? Okay, thank you. Let's just wait for 1 or 2 minutes, then we will start. I hope my screen is visible to everyone.
Yes, ma'am.
Okay. So until now, I hope there would be no confusion related to whatever applications we have discussed so far. How many applications we have discussed related to divide and conquer algorithm? Anyone? We have discussed about the binary search as the very first application, where we have discussed like what is searching algorithm. We have discussed what is linear search. Then we move towards the binary search, which is an actual application of divide and conquer. And we have seen the implementation also of binary search. Further, we will move ahead with the merge sort, where we discussed about that how merge sort will basically work, its recurrence relation, its time complexity, its implementation, everything we have discussed so far, and questions related to conceptual asked in interviews or in exams. So all these aspects we have already discussed. Now in today's session, we will start our newly fresh application that is about the quick sort. Okay. So quicksort is another application. Again, as the name suggests, it is the sorting algorithm. But now what is the difference between quicksort and merge sort, and when to use the quicksort, when to go for the merge sort, and what is the worst case and the best case time complexities of quicksort? All these factors today we will discuss. Okay. So first of all, as the name suggests, why it's called the quick sort? There is a reason behind this. The reason is that it is capable of sorting a list of data elements significantly faster. If you see this word, that's why it's called the quick. Quick meaning, by the name of this only you can remember that, okay, This is the sorting algorithm in which actually if the data elements are all unsorted, it will sort it very much faster than any other sorting algorithm. Second important thing is, basically we used to require three things: divide, conquer, and combine. But you will see in the future sessions that there is no need of combine in case of a quick sort, because partitioning play a very crucial role in case of a quick sort. So this is the very important factor that we will discuss. And just like I told you, in merge sort, merge procedure is the hero. In quick sort, partition is the hero. So we will discuss this particular thing in very detail. Next important, and sorting algorithm. I hope now everyone knows what is the meaning of in place. We do not require any external array, any temporary array to on this. Like we require in the merge sort, we do not require any temporary array in quick sort. Okay. Last but not least, that is the quick sort is not a stable algorithm. I hope this word also is not new for you all. We have done what is stable and what is not stable algorithm. Stable algorithm.
Ma'am, your
Voice
voice
is
is
audible
cracking,
to
ma'am.
everyone.
Ma'am, your voice is lagging, ma'am.
Okay. Just wait a minute. Hello. Now it's better.
Yes, ma'am.
Okay. Please let me know in between if you feel like my voice is not clearly audible. Okay. So from what point it's not clearly audible? From point number 2. Okay. So let me again explain it in a very brief context, and then we will move to the last point. So what I was saying is, first of all, in today's session, we will discuss about the quick sort. So here I told you that the name quick comes from the reason. Why? What's the reason behind that? The list of data elements is significantly faster sorted in case of quicksort algorithm. Secondly, I told you that it is usually based on major part is partition algorithm. So we will discuss in the further upcoming 5 to 10 minutes that what is this partition algorithm, and why there is no need to combine in case of quicksort algorithm, just like we did in the merge sort. Again, this is one of the most efficient. That is also, you will see why. It's an in-place sorting algorithm. What's the reason of in-place? Because here we are not using any external array. I hope everyone remembers I told you the difference between the in-place and out-place sorting algorithm, as well as in one session we have discussed what is the meaning of stable and not stable algorithm. So whenever we require any extra space, it is called the outplace algorithm, just like we saw in merge sort. But in quick sort, you will see its implementation that it doesn't require any extra temporary array. That's why it's called the in-place sorting algorithm. Again, next point I am saying, which is a very important point and which is usually asked in the interviews also, that quicksort is not a stable algorithm. What do you mean by not stable algorithm? Anyone remember? That's what I'm asking with you all. Yes, duplicates order not maintained when we call that it's not stable algorithm. Apart from quicksort, any other algorithm which I told you in the last session, which is not a stable algorithm? Anyone remember? I hope I gave 2 or 3 algorithms which are not stable apart from quicksort. Yes, yes. And the last point, if you will focus on what I told you, that it is a practical sorting algorithm. Why is this so? Because this type of sorting algorithm is applied in projects or real-time application where actually there is a need of applying the sorting strategy. Now, what's the meaning of this word I am saying again and again? When there is actual need. For example, let me share with you the whiteboard. For example, there is an array and someone told you to sort this particular array: 10, 20, 30, 40, and 5. For example, this is the array and someone told you that please sort this particular array. So what you're supposed to do? You will see that this particular array is almost sorted, right? This particular array is almost sorted. That's why there is no need in this particular case to apply the quicksort algorithm. But whenever we are saying that the array is not at all sorted and the size of the array is very huge, in that particular scenario, it's always preferable to apply the quicksort algorithm. And this is the meaning by saying that this is a practical sorting algorithm. Okay. Now moving ahead, now I would like to discuss about the partition algorithm in very much detail. And this is the important algorithm. If someone able to understand this particular part, then quicksort is really easy for him or her. If anyone is not able to understand this particular thing, then this is the only thing I would say which is very important whenever we talk about the quicksort algorithm. So please pay attention in this particular thing. Okay. For example, consider there is an array. Okay. There is an array. Let me take this particular array only. $50, $70, $80, $30, $40, $88, $19, $27, and $69. Okay. Now, suppose the array index will start from 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, what's the thing in the quicksort? Please pay really much attention. Here, there is always a pivot element. We choose a pivot element, and suppose I am choosing the very starting element as the pivot element. What I am saying? Pivot element. This is the element you see after sorting, after first pass. On the left hand side, you will always get the value smaller than this particular element, this pivot element. And on the right hand side, you will always get the values greater than this particular pivot element. How? Now let's pay attention. I am assuming this as the pivot element. Okay. Now there are two pointers. First pointer is I and another pointer is J. There are two persons, I and J, consider. The responsibility of J is to pick up the elements whose value is greater than the pivot element. In this particular case, my pivot element is 50. I'm again saying, consider that the responsibility of J is to pick up the elements greater than the pivot element. And the responsibility of I is to pick up the elements which is smaller than the pivot element. Consider these are the two people, and these two people assign their responsibilities. And the responsibilities of these two people are as follows: that the J person responsibility is to pick up the element whose value is greater than the pivot element. And the I person responsibility is to pick up the element lesser than the pivot element. Now they both understood their responsibility and they're working accordingly. Now there is a sacrifice in between. What sort of sacrifice in between? Let's see. Now J is having the element which is greater than the pivot element, because in my case, the pivot element is 50. The starting element I am considering in my algorithm as the pivot element. So what I am saying that, okay, if the value is greater, Jth responsibility is to take the greater value only. Don't do anything, just move ahead. Now I am getting 80. Again, it is greater than the 50. Jth responsibility is to pick up the greater element. No worries, it will move ahead. Now what will happen? If you will see, the value of 30 is smaller than the value of 50. Am I correct? Value of 30 is smaller than the value of 50. Is my voice is clearly audible now? Everyone listening? Okay. So here, now, what it will do? It will contact with I and say to I that, okay, I am encountering some smaller value. Do you want to take that? Now the responsibility of I is only to pick up the smallest element. He will be happy. But he said that, J said that I will give you the smaller element only when you will provide me the bigger element. Meaning, first of all, the value of I will get, see this step. First of all, the value of I will get updated by one pointer. Then there is a sacrifice here of swapping. I will give the largest element 70 to him, and there is a swap here. Now here 30 will be given, taken care with by the value of I pointer, and the bigger value is taken care by the J pointer. Now again it will move ahead, and he will again get the value which is smaller than the pivot element. Now again what will happen? Anyone? What's the next step? What J will do?
Swap.
It will request I to get the.
Yeah, first step is that he will request I to move ahead, not swap. People used to forget this step and they directly did the swap. This is the problem. This is where they get confused. The very first step is to pick up and move ahead. Why he is doing that? Because no one will give you something without you are providing them something, right? There is always a rule of sacrifice. Okay, you are compromising in this part, so I am compromising on this part. So this is also in case of I and J. I is until or unless I will not give the J higher value, J will not give the smaller value to I. So again, now there will be a swap where I will provide the greater value to J, and now J will give the smaller value to I. This is the important responsibility that the people have. Now, if there is a clash, you have to focus on how they are compromising, how they are sacrificing, how these people are arranging their things. This is the most important and very beautiful thing, I would say, in case of a quicksort algorithm. Look the way what the merge sort did. Merge sort will simply pick up the higher index and the lower index and just divide by 2. And he is able to get the middle element. This is how we did the divide part, right? And we will get O of 1 time complexity in that particular case. Now look at the quick sort. How smartly he is doing the partitioning of array into 2 parts. Now let's move ahead. Again, it will go. Again, what will happen? It is greater. It is greater, so it will not do anything. It will again move ahead. Now again, it will get the smaller. It will again contact to I. I will again get firstly updated. Again, there is a compromise. He will get 70 and this will get 19. Again, there is a shift. Again, there is a value smaller. Again, he will contact to I. Again, there is a swap. And here this will be 27. And here there is a 80. And now the last element is as it is because it is greater than the pivot element. So what can I say? That after first pass, let me write it in a very good way. This is 50, 30, 40, 19, 27, 88, 70, 80 and 69. I hope this is the thing that we get, right? Now the final task is, where is our I pointer? I pointer is here. Ultimately, at last, if you will see, I pointer is here at index 5, 27. And our J pointer is at the end of the array. Now the very last step, after exiting out of the for loop, what it will do, it will finally do one swap with the pivot element. A of I will swap with the pivot element, means 27 will get here and 50 will get here, because this is the pivot element, if everyone remembers. This is the pivot element. So when there is a whole completion of scanning of the array, it will get swapped. And finally, if you will see what answer you are getting after first pass, what value you are getting now. You are getting 27, then 30, then 40, then 19, then 50, then 88, then 70, 80 and 69. Which one is the pivot element? This one is the pivot element. If you look at this side, left hand side of the pivot element, all the elements are smaller than the pivot element. If you look at the right hand side, all the elements you can observe are greater as comparable to the pivot element. This is how it is doing the split. And finally, it will return the index of that particular pivot element. Now, this particular pivot element is at his accurate position after sorting, because final sorted array would be obviously 19, 27, 30, 40, 50, 7, 69, 70, 80 and 88. So if you could observe, this pivot element is at its correct position after sorting. So similar way, if you will see here, now what will happen? Again, there is a recursive call on the left hand side as well as on the right hand side. Again, this will be considered as the pivot element. Now what will happen? On the left hand side, we are having elements 27, 30, 40 and 19. Again, you do the recursive call and apply the quicksort algorithm. Now on the left hand side, again, the same thing happen. Again, this will be considered as the pivot element, right? Now again, this is the pivot element. Pointer I is here, pointer J is here. Now again, there is a check that, okay, this is what we are doing for the left hand side. Again, there is a recursive call. The same thing will happen. The same partitioning algorithm will be applied with the help of this recursive call. Now, if you will see here, what will happen again? This value is greater than the pivot element, nothing will happen. This value is nothing will happen. This value is smaller. Now what will happen? It will contact to I. I will first get updated by one step. Then there will be a swap with 30 and 19. So finally you are getting 27, 19, 40 and 30, where the value of I pointer is here, final, and the value of J pointer is here. And this is the pivot element. This is the pivot element P. Final step is after completion of array, there is one last swap between A of I and A of P. That is 27 and 19. Now, if you could see here, again, 27 here, 19 here, 40 and 30. This is the final array you are getting. And now if you could observe, this is the pivot element. On the left hand side of the pivot element, you are getting the smaller elements. And on the right hand side, you're getting the larger elements. Again, there is a recursive call on the left hand side and on the right hand side. But on the left hand side, there is only single element, which is a small problem. It will directly return the element. On the right hand side, again, there will be a recursive call. How it will go? Again, for 40 and 30, there is a recursive call. Again, this is I and this is J. Now what will happen? If you could see here, the value, and this is P also, this is the pivot element also. If you could see here, again, the value of 30 is smaller as comparable to 40. Then what will happen? It will contact to I will get updated. And then there is a swap between A of I and A of J. After swapping, it will remain its position only, because there is only one position where there is a swap. I and J are at the same position. And finally, the last step is to swap the value of A of I and the value of A of P. So the value is 40 here and 30 here. So what's the final step you are getting here? 19, 27, 30 and 40 on the left hand side. Yes, go ahead. Who is asking the question?
Sunita here. Sorry to interrupt.
Yeah.
How come J exchanges with I when I is not ready to give some value which is greater than pivot here? So you have 40 and 30 and pivot is 40 here. So I will be at 40 and J is at 30. So J inform I that, hey, I found a value which is lesser than the pivot element. Let a value greater than pivot element so that I am ready to exchange. So I tries to parse the array, but it's failed to find a value greater than that. So how come J is ready to exchange the value?
No, means there is an algorithm. No, this is what I'm saying to explain to you. But see, here there is 40 and the 30. Okay. Now our pivot element P is here, our I value is here, and our J value is here, right? Now what will happen? This value is, the purpose of J is to collect the greater value, but it is not having greater value. So what it will do? It will just try to contact with I. Now what algorithm says that, firstly, there is a shift from I to I plus 1. So the pointer will get shifted from I to I plus 1. Then there is a swap. But now after swap also, this value will be at the same position. Am I correct? But now your question is that I is not having the smaller value. So how it is doing the swap? This is what you are saying?
Sorry, I is not having a greater value. So how I is exchanging the data with J? So it is initially 40 and J is at 30. J informs that I found a value which is 30 less than a pivot element. So let's traverse the array and give me a bigger value. So I started from 40 and it goes to 30. It did not find a value greater than the pivot element which is 40. So I
Hmm.
are at same position now.
Yeah, they are at the same position now, and then there will be a swap. Don't I am explaining it like a story, but it's not like
Okay.
originally thing. Means just see on the back of your head
I was
as a
expecting some condition
algorithm only.
here. Actually, I was expecting some condition.
There is a condition. If you will see, there is a logic, and here we are saying that if it is less than equal to, okay, we are saying that if it is less than equal to, so in this particular case it is less than equal to scenario. So here this value will get swapped with itself, and now finally this is the case which will happen when the size of the array is only 2. Okay, in this particular scenario, finally there is, after exiting out of the loop, there is a swap between the value of a of I and a of p, the way we are doing. And after the swap, what it will do, it will get 40 and it will get 30. Okay, so similarly for the right hand side, 88, 70, 80 and 69, the same thing will happen. Now if you could see, is there any problem in the logic what I have said here before going towards the coding part? Anyone is having any doubt? Or nothing is clear, everything is clear? Is it faster? Okay, it's
Ma'am,
clear.
yeah. Can we just for confirming if I'm in the right direction, also do for 88, 70, 80, and 69?
Okay, we will do. So now on the left hand side, we are good. We are able to get the thing right. One thing you can observe, it's always mandatory to observe the things. One thing we can observe here, that whatever be the pivot element, after its first pass, when we are getting on the left hand side all the elements smaller and on the right hand side all the elements greater, you could observe one thing, that that particular pivot element is actually at its exact position, that too after sorting. After sorting, that pivot element should always be at that position only. There would be a replacement of position on the left hand side on the right hand side, but there would be no uh, replacement of that particular pivot element after being switched at that particular point. So this is the final thing that we are getting in the left hand side. Now similarly, there is a recursive call for the right hand side. The same quicksort algorithm will call, and again there is a partition algorithm will call. Now the elements are 88, 70, 80 and 69. 88, 70, 80 and 69. Now again what will happen? This is the pivot element. This is the I value and this is the J value. Right? Now the value of J is what will happen? The value of J is smaller as comparable to the pivot element. So what will happen? The value of I firstly will get updated. The value of I will firstly get updated. Then there is a swap. When the value of I and J will be at the same position, then the element will remain at the same position even after the swap. So 70 will remain at its own position. Again, the value of J will get incremented by 1. Again, it will check, it will see that the element here, it is again lesser as comparable to the value of the pivot element. Again, there is a increment with the value of I. Again, there is a swap, but it will remain at its own position because the value of I and j will be at the same position. Then if there is a swap, even after swap, 80 will remain at its own position. Again, it will go ahead. Again, the value of 88 is greater as comparable to 69. Again, the value of I will get incremented, but after swap, it will remain its own position. Now, the array gets finished. After the for loop, we have made one another swap. The swap between the value of a of p and the value of a of I. So what will happen here? Now there's a final swap between a of I and a of p. So the final array after calling that particular function is 69, 70, 80, and 88. Now, if you could see here, 88 was the pivot element in this case. And all the elements on the left-hand side are smaller than 88. And on the right-hand side, there are no elements present, which is greater than 88. So it will not do anything. But here it will again call the function. Again, there is a recursive call. But after recursive call also, it will remain at its own position because this array is already sorted, I believe. How? If you will see here, when we take 69, 70, and 80, now you can do it at any number of elements, if you get the point. Now here, if you could see, this is the pivot element, this is I, this is j. Now this j value is greater, nothing will happen. This j value will be greater, nothing will happen. Final step is the swap with the value of I and p. A of I and A of p will be at the same position. So swap will, after swap also 69 will be placed at its own position. So final array after the partition algorithm will be 69, 70, and 80 only. So finally you are getting the correct final output on the right hand side as 69, 70, 80, and 88. Okay. Okay, I will repeat once again, but before that, any doubt in whatever we have discussed? Yes, they were. If I and j is at the same position, always obviously you can, it's not a cramming part also. If there is one index only and we are swapping it at its own position only, it will remain its own position. So the value will remain same. Okay. Yes, Sri, how many times do we need to apply partition? Yes. Is it? Yeah, you will see its time complexity also. When we discussed about the code, it would be off and only. At n number of times, we will do the similar step and we will apply the partition algorithm. Okay. Yes. Now,
what's the condition to do the swapping between I and j?
what you are saying? Please repeat.
Priya Sunita here. So when should we swap the elements of I with j?
I'm not getting your question. What you are saying?
When
is the point?
When should we swap the elements of I and j? Let's say I have I at 88 and j at 70.
Whenever the value of j, whenever the value of a of j is smaller than the pivot element, at that particular time, you have to first increment the value of I pointer and then you have to swap the value of I and j.
Okay.
Okay.
Yeah,
I will do it one more time. Don't worry. As a whatever I have did here, just in few minutes, I will again repeat it. Don't worry for that. Yeah.
Yeah, Priya, can you go to slide number 3 once, where the code is there?
Yeah.
Uh, yes. Priya, why are we, I mean, just one question, why are we using less than equal to is one thing. Why not less than? Uh,
Okay.
and second thing, when you consider that unstable format of this sort,
Mhm.
is it just because we are using less than equal to?
No, 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 no.
Okay. And
Uh,
the second thing,
yeah,
I have
okay.
another question. I mean, could you please explain one more example for unstable as well? I mean, for duplicate values as well, if possible.
For stable and not stable, you are saying, no?
Yes, yes,
Uh, these are the problems. Are you able to see the problem number one?
yes.
This problem we will discuss in much depth in ascending, descending, and similar values, which will
Okay,
everyone you will all will be able to get the clarity of stable and not stable, not
okay,
only theoretically but also conceptually. This is the problem number one, and if we are not able to reach until this particular problem, maybe until above recurrence relation only to our today we are able to complete. I'm not expecting that we are able to reach to the problems today, but I would like to request everyone to go and just spend some time and apply the quicksort algorithm. I hope that today you will get the clarity that how we are able to apply the quicksort algorithm. And you all will apply the quicksort algorithm on the ascending order, just like this particular array, on descending order, just like this particular array, and on similar values, just like you are getting the same values. Apply the quicksort algorithm, and you yourself will get the clarity of why it is unstable, and maybe you will get the clarity of what is stable and unstable sorting algorithm. This is the question for this point only. Otherwise, in next session, obviously, we will discuss it in much depth. All the problems, there is already next session will be allocated for these problems only.
sure. Yeah, makes sense. Uh, just less than equal to, if you could explain.
Yeah, that part will also come. Just wait a bit. Hmm. Apart from these points, anyone is having any doubt? Just this code part also I will come just after this theory part. Just wait a bit. Don't focus as of now on the coding part which I have written on the left hand side. Focus on how it is working conceptually. What I am saying, when there is a swap, when there is not a swap, how the value of j and I is incrementing, at which step j is not doing anything, and at which step j is swapping the things. Ultimately, at the very end, what's happening, how the value of pivot element and the value of a of I is swapping at the very last point. All these things, just keep a focus. Coding part, recurrence relation, time complexity, stable, not stable, you will get the at the end of completion of all these slides, you will get every clarity. You can consider any of the pivot element. There is not as such the we can say that on what basis we are considering the pivot element. There's a term called randomized quicksort, which we also discuss in the very end of this session, where it is said that if you will randomly pick up the, here I'm always picking up the very first element as the pivot element. You can pick up any element, any random element as the pivot element, and this is what we called as the randomized quicksort, another name, where what they said that try to pick up the element, pivot element randomly, because anyhow it is giving, they have observed experimentally that randomized quicksort performs better as comparable to the quicksort where we are fixing up that okay, the very first element is the pivot element. Yes, for the quicksort algorithm, pivot element will remain the same during the recursion. But when we talk about the randomized quicksort, or if in an interview someone asks you that, please tell me about the randomized quicksort, usually they used to ask. In that particular case, you have to say that in that particular algorithm, the pivot element will not remain fixed during the entire code. There would be a random generator which usually generate the random value for the pivot element, and that's why the chances of becoming the worst case scenario of the quicksort algorithm will get reduced, and that's why randomized quicksort is much more preferable as comparable to the quicksort algorithm. And all these things again will come in the future session. So don't worry if you don't get any point, whatever I said. Okay, now many people have requested to please go through every step again. So just focus on it again. I'm again going through each and every step, and now with a very good speed also, because I hope now there is no need to spend too much time. But yes, for your clarity, I am again doing it. So what happened? We are having the elements like 50. Let me take the similar kind of elements. 50, 70. Then we are having the 80, 30. Then we are having 40, 88. Suppose I am taking these 6 elements only as of now. 0, 1, 2, 3, 4, 5. Okay. See, whenever we talk about the merge sort, in merge sort, how we are dividing the array, if anyone remembers?
Based on mid.
Based on
Mid value.
Mid value, yes. How we are calculating the mid value? With the help of lower index plus higher index divided by 2, or the good version is lower index plus higher minus lower divided by 2. I hope everyone remembers this point also, right? Now, this thing is clear. How quicksort is better? See how quicksort is dividing. Quicksort is doing the smarter part here only. That's why there is no merge procedure you will see in the quicksort. How? If you could see here, he is considering one pivot element T here. Okay. One ith index and one jth index. Now what he is saying, that the responsibility of J is to collect the value which is higher than the pivot element. If J is encountering any element which is smaller than the pivot element, in that particular scenario, he is saying to value I to please increment and then swap it. What does it mean? Just see this very much carefully. What will happen here? 50 is the pivot element, 70 is greater than the 50. It will not do anything. It will go further. Again, 80 is greater than 50. If you could see, it will not do anything. Okay. Now, in the next step, if you could see, the value is 30. The value is 30, which is smaller than the value of 50. Now what it will do, it will contact to the value of I. I will get incremented by 1 position. And then there is a swap of 70 and 30. This is the thing only which you have to remember. That whenever the J value is encountering the smaller value, which is smaller than the pivot element, in that particular case, J will contact to the value of I, and firstly the value of I will get incremented, and then there is a swap. Only one thing that I am mentioning again and again. Again, then it will go, again the value is smaller, again it will contact to the value of I. Firstly, it will get incremented by first step, then there is a swap. This is 40, this is 80. Again it will go. Now if you could see this value is greater, nothing will happen. Now After after scanning the entire array, the very last step is to swap the value of A of I, wherever the I pointer is, to the value of A of P. That is 50 would be here and 40 will be here. So the final array you are getting as 40, 30, 50, 70, 80 and 88. Now if you could see, this is 0, 1, 2, 3, 4 and 5. The pivot element is at its exact position wherever it should be after sorting of an entire array. Now what will happen? Your partition algorithm will return this particular index 2. Your partition algorithm will return the index 2. So if you could see here, what is happening? This is the partition algorithm which we are studying. This will return the index. The value of m will become 2 now. It is returning 2. Now you are calling, suppose p is the starting index. Now you are again calling this recursive call, quick sort, where you are calling the array A with a starting index and m minus 1. Means now you are calling with 0, m minus 1 is 1. And another right hand side you are calling 2, m plus 1 is 3, and the size of the value q is 6 or maybe 5 in our problem. Meaning what will happen? That now the quicksort function will be called on this part from 0 to 1 and from 3 to 5. There is a quicksort function recursive call is happening. Now again, if quicksort function is calling, it will again check whether the value of p and q are equal. What does it indicate? It indicates that is one element. If in an array only one element is present, we can consider it as a small problem. In that particular case, there is no need of doing the divide and conquer part. It will directly return that particular element. Now it will again check the condition, and because the condition is not satisfying, the value of p and the value of q are not equal value. So what it will do, it will again call the quicksort function. Again, there is a partition algorithm will be called at 40 and 30. Now what will happen? This is the value p, this is the value I, and this is the value j. 0 index and first index. Now if you could see again, the value is smaller. So value of I will get incremented. There will be a swap, but it will remain at its own position because the value of I and j are equal. And final swap is because there is an end of array between A of p and A of I. So the value of final swap will be, this is 40 and this will be 30. So means you are finally getting the final array on the left hand side as 30 and 40. This is the pivot element. In this particular case on the left hand side. Now if you could see, there is only one element on the left hand side present. On the right hand side of the pivot element, there is no element. And here the value of p and the value of q are equal in our code. Starting index and ending index. So it will directly return the value as 30. There is no need to call it again. So on the left hand side, we are getting 30, 40, 50. Now on the right hand side, it will again work. How it will work? We are having 70, 80 and 88. Again, the index is 3, 4 and 5 in our array. Now again, what will happen? This is the pivot element. This is I, this is j. This value is greater, nothing will happen. It will move ahead. This value is greater than the pivot, nothing will happen. It will move ahead. Final step is to swap the value of A of I and A of P. After swapping it means after the function call, recursive function call on the right hand side, we will get the final array as 70, 80 and 88. Again, on the left hand side, there is no element. On the right hand side, again, there will be a recursive call. Again, there is a recursive call for 80 and 88. Again, what will happen? You will get 80 and 88 as the final answer. And again, there is a single element present. So it will directly return that particular element. So finally, if you could see, you will finally get the array as 30, 40, 50, 30, 40, 50. After that, 70, 80, and 88. Just focus on this red marker. This is the correct position after sorting. We have to get the correct position. What's happening here? Any doubt?
Hello,
Hmm.
ma'am, please come on the slide number 6.
Okay. Yeah.
Ma'am, here where it is written, ma'am, 40 and 30
Hmm.
in the last step, ma'am, before LHS. Ma'am, here, ma'am, here 40 and 30 will get swapped with each other. Ma'am, then the value of I and J will point the same number.
Yes. Then you will get 30 only.
Yes, ma'am.
Right?
Yes, ma'am.
After that, array get completed. What's the final step of ours? To swap the value of A of I with the A of P. What is the last step?
Ma'am, swapping of A of P and A of I.
Exactly.
Element.
So what is the value of A of I?
A of I will be 30.
And A of P?
40.
So there is a swap. So you will get 30 and 40.
Okay.
Ma'am,
Go
after completing this one, please share one example of or even in the same example for the random one. Right now,
random we will discuss. See, there is another slide for random. Just wait a little
done,
bit.
done.
Just wait. My presentation is not. What's happening? Wait.
Yes, it's not visible.
Yeah. Wait. I am seeing.
Yeah, I have one doubt. If there are only two elements in the two elements to sort, and if we are using quicksort, then if I is equal to j, and we can compare the pivot element with any I or j, right? There's no need we have to compare with the I.
No, we have to. Otherwise, you will get wrong answer, right?
No. My question is like, suppose we have 40 and 30, okay? And pivot element is 40, I is 40, and j is 30.
You are having 40 and 30, you are saying.
Yes, I have 40 and 30. P is 40 and I is also 40.
Correct.
And j is 30.
Correct.
As now we have to compare P and J.
Exactly.
As,
don't say P and okay. Yeah,
I mean, as A of J is less than A of P. So we have to first increment the I value.
Very good.
And
now you implemented.
Now I is equal to J. And then immediately
there is a swap.
Yeah, right? Immediately we'll be swapping, right?
Now what will happen after swap?
Now P is equal to 30 and J is equal to like I is equal to J, and both will be 40.
Wait. See, wait,
No.
very first step,
Yeah.
very first step is that to check that whether the value of j, whether the value of j is greater than the pivot element or not. If it is greater than the pivot element, just
Then we'll be swapping, we'll be shifting I to one element. We'll be incrementing the I.
we will increment the j. We don't need to
Okay,
touch the
sorry.
value of I.
Yes. We'll
When
be
the
incrementing
value
the
of j is greater than the value of the pivot element, then in that particular case, we're not doing anything. We are just incrementing the value of j.
Yes.
Right? Now,
Yes.
second step, what we have observed. If the value of j is either I'm saying less than or equal to the pivot element, in that particular case, what you have to do? What's your next step? You have to firstly increment the value of I.
Yes.
After that, you have to swap
P and
the
J.
value of A of I and A of j.
But in this case, I is equal to J, right?
Now, yes, I is equal to j. After swapping, this step is happening internally. But after this step, you will get only this, the position will remain same after swapping.
Okay.
There is only one element. I am saying 30. I am saying there is only one position. Swap it. I am saying swap it. I am saying swap the value of A of 0 with A of 0. What you will say? The element will remain at A of 0, right?
Yes.
Yeah. So this step is happening internally, but element will remain its own position.
Okay. As I is equal to J, so we both are same. So internally the swapping function will be happening. And
Exactly. After that, this is happening until your loop I in range. There is a for loop from 0 to n. For I in range I'm just writing the pseudocode. For I in range 0 to n, this step will happen. These two steps. Now focus on the last point. Very last point. After exiting out of this loop, when all the array will get finished, what is the final step I told you? Last step. After exiting out of the for loop, what is the final step? Anyone?
pivot.
Swapping of P and I.
Exchange the pivot with I.
Exactly. Now our last step is to swap the value of A of P with the value of A of I.
But Priya, why did you write for I in range of 0 to n? It should be for j, right? Isn't it? Once we
Right, correct.
j.
Yeah. Not 0 to n. Oh my god. Wait. Yeah.
I to n, I plus 1 to n.
Yeah. It would be from, because the value of j is from I plus 1. We are always at one step ahead with the value of I. So it should be equal to I plus 1. Suppose the value of I is 0, the value of j will be 1 to n. So it will go. So this is how basically internally this is working. So now coming towards this particular question only, I don't know who is asking. So 40-30, so it will internally happening. The swap will be there. Now the final last step, because now it will go out of the loop. Suppose there is two size arrays, 0 and 1. It will go out of the loop. After coming out of the loop, there is one final step which is left. That is to swap the value of A of P with the value of A of I. Now, what is the value of A of I? 30. What is the value of A of P? 40. So there will be a swap, 40 and 30. Now consider that if the value of I is not shifted to any other location, it's okay. In that particular case, it will not move its position. Suppose the value of I is not shifted, it will remain its own position, and the value of P is also at its own position, then it's fine. After swapping, it's not like swapping is not happening. Internally, swapping is happening, but you can say that after swapping, it will remain its own position. So finally, output of this particular array you will get as 30, 40.
So it is all the time the swap is between P and I.
After completion of the array, at the very end, the swap between P and I. Internally, in between the loops, the swap is between A of I and A of J. And that too, firstly, you have to increment the value of I. After that, you have to swap. People usually forget this step. This step people usually forget.
Okay, I got it.
They directly do the swap thing. This is also
once the range is completed, then only always the swap is between P and I.
Yes.
Oh,
There's
okay.
always one time swap there, right?
Yes.
This is only the last step, which is only at one time. This will happen only one time.
Okay.
This can happen many number of times.
Okay, the swap between the increment and the J increment can be happen as many times, but the swap between pivot and I is only once, that too in the last step.
Yeah, when your you already scan all your array completely, from starting from 0th position to the n-1 position.
Okay, I got it clear. Thank you.
Yeah, can you go to the algorithm side one? Quicksort algorithm.
Don't focus on these things. I will explain a bit.
What is M there? M is just some
M is
index,
the
is it?
index. So what is this partitioning algorithm is returning? As I told you that it will return the index. It will not returning the 50, or it will not returning the array. That point is also you have to focus on. You are applying the partitioning algorithm. Now it will return the exact index of the 50 element. 50, once it is placed to the exact position, it will return the index of that particular element. That is 2. Now our system knows that 50 is at the correct position, that is at the second position. Now I have to focus on the elements which are at the left hand side of the 50 as well as on the right hand side of the 50. So again, we will call the function on the left and the right hand side. So this is what it is returning. If you could see, it will return the index 2. Now again, we have to do the thing on the left hand side as well as on the right hand side.
Thank you, Priya.
Exactly. In merge sort, we are calculating the middle element, and accordingly we are doing the partition. Here the partition function is returning us the middle element. Like, this is the smartness of quicksort, that he is calculating the middle element, that from where you have to do the partition, from what will be the point, exact middle point from which you have to divide your array on the left and the right hand side part, and accordingly you will do the things.
Can you just go to the partition algorithm slide one?
What's the doubt?
No, I'm just going through the logic, the way you have written the code.
Yeah, code I'm explaining now. Should we move ahead the code? Are you guys able to understand the logic conceptually? Now should we move towards the coding part? I am removing the things which I have written.
Yes, Priya.
Okay. So let's erase this so that we get better clarity of the code now. Okay. Now if you could see here, consider the value of P as the first index, that is 0th index, right? Lower index, I would say. And the value of Q as the higher index. So value of P is the lower index, consider. And the value of Q as the higher index. Okay. Just consider like that. Now what I told you, that the value of starting in an array, the starting value, the lowest index value is the pivot element. So here consider that X is the pivot element. And I want, after explaining the code, pseudocode today, everyone please go and try the code implementation by your own. In the next class, I will run the code on the collab file. But before that, today itself, please try. Now you have understood the logic conceptually. I am explaining the pseudocode also. Now it's your time. It's just same thing. It's not that all difficult. Just go to your home and try to run the code on the collab file and let me know that how many people are able to get the correct output after running the code. Anyhow, in the next session, we will run the code also and I will show you the correct output. But first of all, I want from you all to try at least once. Now you are capable of writing the code also. Okay, so just understand the pseudocode clearly. Whatsoever doubt you have, just ask me. And today, everyone, please try to run and send me or mail me the collab file if you are able to get the correct output. Or if in case you are facing any issue, please write in the comment section on the mail also. I hope everyone is having my email ID. I will try to give the feedback as soon as possible. Okay, now you have the time, 1 week. So please everyone try. So let's move ahead now. Here the value of X is equals to A of P and I am saying that the value of X is the pivot element. Now here as we took I and J, similarly I is the, as I told you, P, and the value of J will start from P plus 1. Now it would be go until the value of Q. It is less than or equal to Q, J plus plus. Now coming towards this condition. This is important. What we are doing here?
Whenever we encounter a lesser value, we will let the I to increment and swap the values.
Yes. So what we are doing here, if you could see here, this is the value I according to our code, and this is the value X because here X is the pivot element. Am I correct? And now our J value is starting from this point, right? And the value of Q is this. Okay. Now, what will happen? What we are doing here? This is what I think I have mentioned many times, that if the value of J, if it is greater, means if J is encountering to the value which is greater, we don't need to do anything. It's just directly to the J plus plus task, means incrementing the value of J. Where we have to focus more? when the value of A of j is less than equal to the pivot element. If the value of A of j is greater than x, then there is no need to do any task. In that particular case, it will directly increment the value of j. And this is what we are doing. The main thing that we have to focus on, that what will happen when the value of A of j is less than equal to x. In that particular case, what we want for the very first step is to increment the value of I to I plus 1. This is the very first step that we have to focus on. And then you have to swap the value of A of I and A of j. Now, I hope everyone knows how to swap the values in Python. It's very easy task. In Java or in C++, we have to write 3 lines of code, but in Python, only 1 line of code. So we directly swap the values of A of I and A of j.
Ma'am, we don't need to take temporary variable while swapping.
What you are saying?
We don't need to take a temporary variable, temporary value while swapping.
No, we don't need to take any temporary variable.
Okay.
In Python, we don't need to take.
Then why do they take a temporary variable while swapping normally?
Where we are taking the temporary variable?
Not here, ma'am. Generally in C++, bubble sort and all, if you take
that we will discuss later. Just completely focus on this point as of now. Okay, don't switch. Now what we are doing here, that point we will discuss. It's not important actually to take the temporary variable in C++ or in Java also. There are so many ways to swap the values. Okay, so that point is completely different, but as of now, completely focus on this algorithm and complete it. Okay, now after doing what I am saying is that after completion of this array, once it will get completed, this for loop will get completed. If you will see here, what's the last step I told you? After completely scanning of this particular array, suppose you reach to this particular point. Now your condition is not satisfying. What you supposed to do? This is your last task. Step number 3. To finally swap the value of A of P, that is the pivot element, with the value of the A of I. And as I told you, what is this partition algorithm is doing? We are finally returning the value of I. We are finally returning the value of I. Because if you remember, what is the value of I? If I have mentioned here, see here, what is the value of I here? 2. We are swapping and we finally get the value of 50. The pivot element exit position is 2. So this is the value of I. So in partitioning algorithm, we are returning the final index of that particular pivot element. And what is the index of that particular pivot element? That is I. So this is what we are returning. Simply speaking, this value is, you can say, is the mid value. In merge sort, we used to calculate this mid value with high plus low divided by 2. But here we are calculating this mid value with the help of this one procedure. Now, according to this particular value, our algorithm will decide left-hand side portion and the right-hand side portion of the array, where it again need to scan it again and again. Now, if you will completely focus on this, can anyone tell me what is the time complexity of this whole procedure, what you have seen so far? Just think over it and tell me what is the time complexity of this particular code and why?
Partition is n.
Why?
Because we have a linear loop over there and which start from P to Q.
Exactly.
So that means
we
the length of the subarray, whatever we get.
Exactly. Correct. So here we are having only, suppose we are having the n number of elements. starting from the value P to the ending point Q, and we are having only, if you could see, one loop, which we are traversing from the starting position to the end point. And inside that, there is only conditions, or if condition, or there will be a swap, or there will be an increment, and everyone knows that this would not computationally expensive task, which is the major focus for calculating the time complexity, our looping part. Everyone, we all knows as of now, right? We have seen so many sessions on time complexity part. So overall time complexity, if you will see here, it would be O of n. Now, after getting this particular partition part, just completely focus on this part also side by side before distracting into another question or another point. Now what will happen? Let me remove everything here. You will call this function. I hope now this part is clear to everyone, how this is working and what this is returning. Any doubt in this part before coming towards this major quicksort algorithm, how it is working? You have to do today. Now in this week, I'm expecting from everyone to give me the correct implementation of this algorithm. So if you have any doubt, please ask me. Maybe I will pick one volunteer, and that person or that student will explain in the next class the correct implementation of quicksort. Accordingly, listen everything. Everything clear so far? Easy or difficult? Not easy, not difficult. Moderate. Shallow be smart. Yes, two functions you have to return. One function is for the partition, and another function is for the quicksort, recursive call. Very good. So you have to write in your file two functions. And please, we used to have the habit of whatsoever code we have, firstly we will go to GFG, copy paste, and then we will understand. Now you know the logic, now you know the pseudocode, everything you know. Don't do that, please. Go to the directly collab file, start writing the code. Before that, if you want, just do little bit things on the copy pen, just for your understanding, just for your weight of thinking the things. Because if you are seeing these for the very first time, it might be the case that you will feel it's quite difficult for you. But don't do copy paste now. Try to do it on your own. And if you face any difficulty on the Skype chat, just put it up. Many people will be there to help you out. Right?
Can you
now,
repeat once again what you said?
What you are saying?
What you said, can you please repeat? There is a connection issue.
I was saying that don't copy paste the code from any other source. Try to write the source on your own. Now you know the logic as well as the pseudocode. So I am expecting everyone that he or she will be able to write the code very much easily. And if still you are facing any issue, just post it on the Skype chat and try to ask the questions, try to seek help from others. Those who know the things, please do help others. This is how everyone will grow. Right? So let's move towards now this second part of the code, that is the quicksort algorithm. Now, how we are calling it recursively? Obviously, we have to think the bigger problem and the smaller problem. The way we are doing in the divide and conquer from the very starting of the session, this is what we are doing, right? So if the problem is small, and one more thing I want to mention here, that please do write the comments whenever you are writing the code in the Colab file or in any other source. It's a very good habit to write the comments, so that if you are sharing your code to any other person, XYZ, if someone is asking you to please share your code, and if you are sharing to him or her, it would be understandable to him or her. For example, you are taking P and Q and you are not even saying to him what is P, what is Q, how that person will be able to understand. And no one is having that much time to sit with the code, with a very simple code for 2 or 3 hours to understand your variable terms. So just try to mention everything in a comment section or in a text box and do accordingly things. Okay. Now, this is the P, which is the starting index. Q is the ending index. If the problem is small, what is a small problem? If in an array we are having only single element, in that particular scenario, we directly return. This is what I think we did in the merge sort also. Otherwise, we have to find the middle element, which we will calculate it with the help of the partition algorithm that we have studied as of now. After that, now we know that this partition algorithm will take the time complexity of O of n. Then we will call the quicksort on the left hand side, which is taking the values parameters as p m minus 1, and on the right hand side, which will take the parameter as m plus 1 to q. And finally, we are returning after completion of all these things. Finally, in our quicksort function, we are returning the array. So what it will do, it will return the full final sorted array. Now, if you could see here, what is this? This is the recursive call. Now, why I mentioned like this in quicksort, in merge sort, if you remember, we used to write like this: t of n by 2, t of n by 2. Why I haven't written like this here? Why I am written in many resources you will find in quicksort also this form. Is anyone saying something? Please repeat. Okay. So what I was saying that in merge sort, we used to write it like this. If everyone remember, whenever we are calling the recursive call, we used to write t of n by 2 and t of n by 2. But in quicksort, I am not writing it like that. And I am saying that in many resources, in many books also, I'm not talking about the standard books, but in many books, usually there is a mistake. Many people in many books also, it is written like that. It is wrong. For quicksort, I am saying. Why it is so? Anyone?
The partition is exactly
Because
not
we
the
are
name
not
of
sure
the
that
array. It might be the partition in the quicksort is uncertain.
Uncertain meaning?
I mean, if suppose the partition algorithm, the partition subproblem, if at all it is like I, and I value, it might be in the second element or third element or fourth element. So we may not predict the value of I over there. So hence we are writing this.
Yeah. So many people have suggested this right answer and the same answer, that here we are finding out the middle element with the help of the partition algorithm. And partition procedure is returning the value of I. Now that value of I, we are not 100% sure would be at the exactly half location. Half location meaning it's not like that only fifth element is the value of I and 4 elements would be there and 4 elements would be there. It's not like that only at the fifth index exactly we are getting the elements. But what is happening in case of the merge procedure? In case of merge algorithm, we are always getting the middle value as 0, or I would say low plus high divided by 2, which indicates that on the left hand side and on the right hand side there are equal number of elements. But in this particular case, when we are calling the partition function, it's not sure that there is always mandatory condition that the left hand side and right hand side always have the equal number of elements. So that's why we are not write it like that. We can say how many number of elements would be there in the left hand side? It would be m minus p. How many number of elements would be there on the right hand side? It would be q minus m. How we used to calculate the number of elements? Anyone?
Based on the I value.
Here, how I am writing m minus p and q minus m? If in my array, the starting index is p, ending index is n minus 1, what is the formula to calculate the number of elements?
High minus low.
High minus low plus 1. This is the formula to calculate the number of elements in an array. So if you will calculate here m minus 1 minus p plus 1. So m minus p is the total number of elements. Similarly, if you are having m plus 1 as until q, so this would be q minus m minus 1 plus 1. So you will get q minus m. So these are the total number of elements present on the left hand side as well as on the right hand side. So here you will get t of m minus p and t of q minus m. Now, with this part only, very important point. So we get to the point that if the value of n is equals to 1, this is a small problem. We will directly return it O of 1. If the value of n is greater than 1, in that particular case, our time complexity will be n, which is for partition, t of m minus v, which is for left hand side, and t of q minus 1, q minus m, which is for right hand side. I hope this is fine. This part is fine for everyone. Is this fine? Now we are moving ahead towards the very important part. Is this point is fine? Any doubt in this? When the value of n is greater than 1, how we are getting this n plus t of m minus p plus t of q minus m? Is this part is fine for everyone? Okay. Now, after understanding this thing, we have to see the very important point, that is when there will be a best case scenario and when there will be a worst case scenario. And if you could see, focus on these two things now. Very, very, very important point. Again, I am saying, when we say the best case scenario, obviously we would say that if the value of m, which is returning by the partition function, is divided in such a way that on the left hand side and on the right hand side, we are having equal number of elements, then we can consider it as a best case scenario, which we usually see in case of a merge sort also. Meaning, if we are on the left hand side also, we are having n by 2 elements, and on the right hand side also, we are having n by 2 elements. That would be the best case scenario. So in that particular case, what will happen? We will get n plus 2t n by 2. Solve this recurrence relation with the help of the Master's theorem. You will get the value as O of n log n. Am I correct? Is this best case scenario is clear to everyone? What I mean to say? For example, if not clear, let me give you one example also. Let me give you one example also. For example, I am having an array like 20, 10, 30, 60, and 50. Suppose this 30 is the pivot element. After first pass, we are getting this as the left-hand side of the array. After applying the partition procedure, we are getting 2 elements on the left-hand side and 2 elements on the right-hand side. And just directly in between, we are getting the value of m, which is returned by the partition procedure. This is the case of a best case scenario. Or maybe like this, 30, 20, 10, 60, 40, and 50. This is also the best case scenario. It's not like always 2 and 2 elements would be there. It would be the ratio of 2:3, 3:4, 4:5, and so on. What I mean to say is that on the left hand side and on the right hand side, difference is not that much big. Number of elements is almost equal. In that particular case, you would say it is a best case scenario. When the value of m is exactly in between, or I would say is almost in between. In that particular case, your recurrence relation will be equals to n for partition part, t of n by 2 for the left hand side part, recursive relation, and t of n by 2 for the right hand side part, recursive relation. And then you have to solve this n plus 2tn by 2, and with the help of Master's theorem you can solve it, and you will be able to get the value as n log n. O of n log n for the best case scenario. Is this fine as of now? No. Best case isn't the best case array is already sorted. Never. When the array is already sorted in quick sort, you will get the worst case thing. Why? That also I will explain to you. N is this n you are talking about, Sameer? Is this n you are talking about? N is the time complexity of the partition algorithm that we have already discussed. How much time complexity you are getting for that partition? Obviously, when the value of n is greater than 1, means in the worst case scenario, when the value of n is really large, in that particular case only you will call the partition. For that, you will have the time complexity of n plus left hand side recursive call plus right hand side recursive call. So here I am talking about the best case scenario as of now. And this is not omega. This is big O. Why this is big O? In best case scenario, we are saying that it would be big O and log n. Big O simply indicates that when we are considering the value of n as very large, in that particular case, the value will be n log n if it is divided in such a way. Now consider the worst case scenario. What will happen in worst case scenario? That thing is very much important to understand. Now consider one case where you are having on the left hand side elements are smaller than 10. If you could see here, this is highly imbalanced. There is only one element on the left hand side and remaining all the elements are on the right hand side. Are you able to understand the difference between the best case and the worst case scenario I am talking about? This is the worst case scenario in which your m value returning by the partition algorithm will be 1. Suppose this is the index. What partition algorithm will return? It will return the value as m is equals to 1. Now it will call the left hand side and the right hand side. If you could see here, at one part only there is function call, and in one recursive call, it is have to solve only one element. And on another part of the recursive call, all the remaining elements are there. too much burden on the right hand side and there is no burden on the left hand side. Even it's a small problem. So that would be the worst case scenario. In a quick sort. And this can happen. And this can sure happen when your array is already sorted. Someone mentioned that the best case scenario in quick sort should be when the array is sorted. It's not the case. When the array is already sorted, that's the worst case scenario in case of a quick sort. That's why if you remember in the very first slide I have mentioned that use quick sort only when there is a practical need. By meaning this, by meaning to say this point only is that when you actually want to sort the array, then only go for the quick sort. Otherwise, there is no need to go for the quick sort. And if you don't know the structure of the array already, that whether it is sorted or not, don't try to use the quick sort. Always go for the merge sort, because in merge sort, the worst case time complexity would be n log n. But in quick sort, if you could see now the recurrence relation, there is only the structure is it's not at all, you know, overall structure. It's not n by 2 now. There is n minus 1 number of elements on the one portion. N is for the partition procedure, the same thing. And only one element is in the left hand side. Remaining elements are on the right hand side. Now, if you could see here, for this particular element, there is no need to call the recursive call because this is a small problem. So only one recursive call for this right hand side. So it is having T of n minus 1 number of elements. Why n minus 1? Because this element you forget. Now we have to focus on this particular part. And if you will calculate this time complexity again with the help of any substitution method, you will get to know the time complexity as O of n square.
Isn't it a factorial?
What is this? Which one?
No, I think I have to work on it. I thought it's a factorial, but it is not n into t of n minus 1. It's n plus.
Yeah. So what we have observed that for merge sort in every scenario, we are getting the same time complexity, which is n log n. But when we are talking about the best case scenario and the worst case scenario in case of a quick sort, we are getting different time complexities. That is n log n and n square. And you have to remember the scenario in which case you are getting the worst case thing. As I told you that when your array is already sorted, in that particular case, you will sure getting the worst case scenario. And that you can try with these particular questions. Now, your homework for today is to try these particular, at least this first problem I'm expecting. Don't go for second, third, and so on. But at least these three parts, you try and let me know that what is the time complexity you are getting. Yes, go ahead with the question.
But if that is the case, means like when should we apply this algorithm? Most of the times like, we don't.
Yeah, we should apply the quicksort algorithm only and only when you already know that the array is highly unsorted. It's not at all sorted. In that particular case, it behaves much better as comparable to merge sort. As I already told you, it's significantly faster as comparable to the merge sort. But as you said that in most of the cases, we don't know the scenario that how is the structure of the array. In that particular scenario, always go for the merge sort without taking any risk. That's why today also in many of the standard libraries, whenever we used to call the sort, and by default in the backend sorting is happening, only and only merge sort is applied at the backend by the developers, because we don't know the what the user is doing. For many purposes, it would be used for practical scenarios only, obviously, when the array is highly unsorted. In that particular case, only people used to sort the array. But then there are some scenarios in which array is already sorted. For some numbers we used to sort, then never ever go for the quick sort. Okay, any other doubt?
Can you give us some example like where this algorithm is applied in real life?
In various projects, in various real-time projects, where in product-based companies, whenever there is a need of sorting part, usually quicksort 80% of the times we have applied, because we used to ask the need from the client that, okay, what are the needs and how is the structure, whatever input people, customers used to give in. They told them then, okay, these are the things which we are expecting from you all. And some people say that, customer says that, client says that it's okay if at sometimes it will behave like abnormal, it will behave, it will say the answer late, it's fine for us, but our priority is to give the correct answer in a faster range. In that particular scenario, if the customer is okay, if the client is okay that for some scenarios it will behave like very late, but most of the times you will get the output very fastly, in that particular case we have to go for this quick sort only. So in real time projects, maximum time we applied the quick sort only. But in the libraries, I am saying, whenever we have the predefined libraries, in those particular things, when we don't know, there are the students from the very freshers who are just beginning, they don't know, to the people who are using the libraries and the companies, in that particular case they don't want to take any risk, so they applied the merge sort in those scenarios. But in office, in companies, in various projects, we used to apply the quick sort only in the backend.
But we don't directly interact with the business people, right? Like they don't know the algorithms, and if we tell the complexity also,
No,
it will be blind.
no. We don't talk. It's not our purpose to talk to the customers to see the requirements of them. And these people and this team is completely different in the companies. And they used to talk not only in terms of the complexities, they talk in terms of the time. They say to the people, that to the clients, that okay, there comes a time where you're if you are passing such type of input, or your customer is passing such type of input, your response will get late. But yes, in most of the cases, if that would be a practical thing, you will get a very fast response. So is this thing is acceptable to you? Otherwise we will have another solution to work on. Please tell us. Now those people will tell to them that it's completely fine for us. It's not most of the times, maybe 95% of the times, our requirement is of practical needs only. But if in any scenario, if the customer put wrong numbers, then also if it's behaving too late, it's completely fine, because its probability is 5 by 100, that is 0.05. But 95% of the times our needs are fulfilling that too faster. Why to go for that particular delay response? So all these things are there. There is another team which properly marketing team which properly talk to the customers about their needs, about their each and every aspect, and they don't usually talk in terms of the complexities. Then those particular people will talk to the developers regarding, okay, this is a thing that customer want. Now you will think that in how many ways, or in what way you can fulfill their demands. Then we can think over it that, okay, if they're happy with this kind of behavior, then okay, why not to apply the quick sort? They will be happy for that. And if someone is saying that no, it should not be like that, we don't want any delay response, it would be fine if we are getting the responses equal number of times, then go for the merge sort. So this is
But see,
in the back of our head.
products
Yeah.
in the market, one is we have two kind of functionalities which will be fulfilling our need. So one will be like irrespective of whatever the data that you give, it's a good data or sorted or unsorted, we don't have any restrictions on the data structure. I mean, the data is arranged. They give even in a worst case also, they behave in a one constant manner, like n log n. And we have another product where it's completely depending on the structure of data that we provide. If we give a best structured data, it will behave in the same manner of the other one, n log n. Otherwise, behave in worst way, like n square. So if that is the case, means everybody will tend to choose the first product, right? Then
no, it's not
there
like
won't
that.
be.
You yourself think that how many times this type of scenario will happen? Means we want to do the sorting. Everyone knows what's the meaning of sorting. Who is the stupid who will give this type of array? It's a very, it depends what, it's very rare chance that people used to give such type of things. Yes, but that, by saying that, I don't mean to say that it's not applicable. What I mean to say that merge sort is, that's the only reason. The point that you are saying is the only reason of today using the merge sort in terms of any library, in terms of any use. That's the only reason, because people used to prefer that in worst case scenario behave equally. But then there are some real-time projects where people know that this type of certainty is very less. No one will do that. They knew it really well. If they prefer, then only people can apply the quicksort. And obviously, for everything, there is some pros and cons. That's why we are studying. We are studying quicksort because it's comparatively very, very, very faster as comparable to any of the sorting algorithm that we ever studied so far. That's the, you can say, pros of quicksort. And that's why today, even after its worst case scenario, it can be usable. So it's having the limitation, but it depends that is this limitation is too much that we completely avoid that, or what are the requirements of our what are the requirements that we have. It's completely, but yes, as a developer, we should know end to end everything, that okay, at what scenario we should go for what algorithm. And that's the only reason to study each and every aspect in very much detail. Okay, if you don't even know that what its pros and what its cons, then you can't compare it with another algorithms. And there is not only two algorithms. For sorting itself, there are 9 to 10 sorting algorithms. And for every sorting
My
algorithm,
question is like,
I would say that there is something good in that and something bad in that. Now, it all depends on the requirements of your project. According to that, you will decide that where should you go on. Yes.
actually, I couldn't see it anywhere that it is faster than the merge sort. Maybe I might be wrong. Even the best case scenario also, it is n log n, and merge sort with the worst case scenario also, it is n log n. Maybe with the best case scenario, it might be better than n log n. So when comparatively with the merge sort, I couldn't see anywhere that quick sort will be faster. Maybe
no, it's actually faster, and it's well written in many of the standard books that when they are dealing with very large numbers, and they saw the performance of the merge sort and the quick sort, because we are talking about the approximations. N log n, it seems to us that okay, it's same only, right? N log n, O of n log n for the merge sort, and O of n log n for the quick sort. But when those people did the experiment and took the very large value of n, and on one system they did the quick sort and try to do that sorting, and on one system they are applying the merge sort, they find out that as comparable in terms of time, I am saying quick sort did the task very much fastly as comparable to the merge sort also. When we are giving the input in such a way that array is completely unsorted, that's the constraint they have said. So this is the thing. Apart from that, now I told you two things today to do. First thing is that you have to work on this particular problem, and second thing is that you have to apply the coding part on whatever we have seen so far on the implementation. You have to apply on the collab file and report me the collab file as the result, and whosoever will get the, I will feel that it is best in terms of the comments and its understandability. Maybe I will give it to the team and they will post his solution by his name or by her name on the dashboard. Fine. So these two things you will try, and then any other doubt?
Yeah, Priya. Hi, this is Nafisa here. I actually I have two doubts. Firstly, related to this quick sort. So you explained two algorithms, partition algorithm and quick sort algorithm. So while doing the problem one, we should write both the algorithms together to get the final result, right?
Yes, yes, yes.
When
if you will see quick sort here, wait, if you will see quick sort here, we are calling this function, right?
Yeah.
If we are calling this function, we have to define this function in our code. This is the function definition. Yes.
Okay. Okay, I got you. And the second question was related to the challenge which you have given yesterday.
Yeah.
I just wanted to know the minimum number of members which could be there in one team.
Don't make it too large because it would get complicated by your side only. I don't have any problem. If you want 8 or 10 people in your group, I don't have any problem. But it would be struggle for you to collect each and every time for meeting purpose and for everything. Make it 4 at least. But I'm not putting a constraint that it should be 4. I'm just advising you all that don't put it too much large. You yourself get messed up with that much group size. It should not be too much small and it should not be too much large. Make it 4.
Okay, okay, not 6.
6 you can, if you know, if there are friends of you and you think that you can manage, then go for 6. I don't have any problem. Okay. 4 should be the optimum size, I believe that. But if you feel like in 6 also, or in 8 also, in 10 also, you feel like we can manage, then it's completely fine for me. But as I told you, that please mention the details of the group by make a column of group number. Write it group number 1, team members name, team member 1, team member 2, team member 3, team member 4, team member 5, team member 6, 7 and 8 and so on, and just make the names of that particular group members. And if there is some remarks, make the column for remarks also if you want to mention any comment on that. Shri, it's just a system challenge. If you will see on the dashboard, there is a system challenge. I'm again explaining, and just go to that. And if you want to work it alone, then also it's fine. If you want to work in a group, then also it's fine for me. But if you are working in group, it's a small request to just mention the group names and start working on that. And just go to the dashboard and see the challenge, what is that and how we supposed to do, and accordingly decide. Okay, so let's end this today's session. We'll meet on the doubt clearing session, and there are many requests for the students to get them understood the OOPS concept, because these OOPS concept are also asked in various interviews. So I decided to in the doubt clearing session, I will just cover up this OOPS concept also. And there is one question asked by the Kevin. He also mentioned in the doubt clearing session sheet. That also I will discuss in the doubt clearing session. These two things I will cover. Yeah.
Ma'am, this OOPS concept is very much important. Can you please take it on Saturday rather than on doubt clearing? Because on doubt clearing, I always not join, and many people others don't join, and this is a very
Anyhow,
important
you all will get the recordings, no? So I don't want to touch in these sessions on regular sessions, because we are covering very important topic, and if we touch these topics in this session, then again our syllabus will get delayed. It's already due to
Okay. Okay.
sessions we already are moving
Sure, ma'am.
delayed only.
Okay.
And what I am thinking, it's not a issue if still it's not, apart from this oops concept, if you think that there are some important topics which used to ask in the interviews, and you want me to explain, and it's not like on Tuesday only. If you are feeling that okay, Tuesday I'm not comfortable, in the weekdays, anytime, now I am available from Monday to Friday, anytime at night, you can just mutually decide and let me know. On that day only I will conduct a session, maybe in the morning or in the evening or at the night. You can let me know accordingly, I will schedule myself. But try to be there in the class. And apart from this session oops concept, if you think that there is some topic which should be discussed, this syllabus is going on. Okay, on Saturday Sunday we will continue the sessions whatever we are doing, because we have to complete the syllabus end to end. This is what I want at the end of 6 months, and I don't want to get it delayed. It's harming me as well as all of you, because many people are preparing for the placement purpose, so I don't want to get delayed this part. But what we can do apart from that, if you think that there are many topics apart from the syllabus which we are doing, for example, many people are saying oops concept, that's why I'm coming up with that. If you think that okay, this is the topic which I think we can conduct a session, and you want me to tell you some things on that particular topic, please let me know. I will prepare the things and I will let you know all. I hope that everyone knows my profile very much clearly. If not, then I have a website also, you can look at this. And if you think apart from this also that okay, in this particular scenario I can help you out, just let me know. All these things we will conduct in the doubt clearing session. By making that particular session much more productive, you can see the things, and if you feel like okay, in this way I can help you out, and in this way it's important for you all to conduct this particular session and for interviews in terms of anything, okay, just mention the topics in the doubt clearing session sheet. I will prepare the content accordingly, and we'll do the doubt clearing, all these things on the doubt clearing session itself. Because what I feel is that these 2 hours we are not properly utilizing in the doubt clearing session, and I want to utilize those particular time also very much importantly, so that whosoever is coming on that session, they will listen something good and they will get something good from those sessions also. Just like in these sessions you are listening, and for 2 hours we are doing the things. Okay, so we will try to make that particular thing happen in that doubt clearing session also. We will try to conduct for whole 2 hours, or maybe 2.5 or 3 hours also, if time permits to
Which
us.
language you use for explaining the doubt clearing session? Is it again Python?
It's not
I know
it's
that
not it's
mostly
not
in conceptual
compulsory.
way.
If you want to have any doubt in Java, you can ask me in the doubt clearing session. But I don't want to disturb this classes Saturday Sunday going on. Just try to cover up the syllabus in these classes, and whatsoever doubts you are having apart from the whatever we are discussing, just go and just we will conduct many more sessions on the weekdays. In this 1 month I can conduct, actually I have the time. That's why I am saying to you all, please utilize the time. I want to utilize the time with you all for all these things, for all these aspects. And if you feel like that okay, this is the thing that I want to clarify, just make proper use of that. After that I won't be able to get proper time apart from Saturday Sunday, but now I have. That's why I want to give it to you all. Okay, so that's the main thing, nothing beyond that. Okay, then just let's finish this session.
We have 3 questions, right? problem 1, 2, 3, sorted, unsorted, I mean, ascending, descending, right?
Yes, as well as the implementation part you have to try for the quick.
The implementation, we have to write the code for these problems. Like you want us to give the values in this way as an input, or what we should be doing for this?
You have to give the values in this way, and you have to apply conceptually the quick sort, just one by one, step by step, the way I am doing.
Okay.
I was doing right.
Tracing. Okay.
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 Okay then. Bye bye everyone.